Hello, my name is Jožik, and in this video I show you a character controller using a finite state machine and the new input system. The input system consists of moving and standing, so the idle state, crouching, jumping, and sprint. Now in the editor we first have to install the input system. We go to Window, open up the package manager, and then under package Unity registry we can choose input system and install it. Then we have to create a new action map by going to create, input actions, and then name it like player controls, double click, it will open up here and we can create a new action map like this. I have already created one for the player. I have actions for move, look, jump, crouch, interact, and so on. Now for move, I have this one 2D vector, digital normalized, and I defined every button like this. I have up, down, left, right key, WASD. For the jump action I have just a button, the space key, crouch, C key, and for sprint I have an interaction which is called press, the trigger behavior press and release. You get an hold behavior, so that can hold down this button, the shift button, and the player sprints while this button is held down. Now let's go to our player object. I have here this component player input, where I choose my default map for the player, which we just created here, player controls, and just drag it in there. That should work. For the camera I use just a Finite Machine, but that's for another video. So just put in your main camera here. This character controller script here from Unity. We use that to move the player actually. Then there is a character script, which I will explain in just a moment. And here the Animator component. Now let me explain you the Animator component. When we open up the player animator, we see that we have different states, so different blend trees actually. The first one is the locomotion blend tree. When we open it up, we see that we can change between different animation with a parameter speed. This parameter is defined here, is the float value and is between 1 and 1.5. Now 1 means that the player is in the idle state, which is just moving on the place a bit. Now when we change this value to like 0.5, we are in walk state, around 0.5, player is walking. And when we go actually a bit faster, like to 1, you can see that the player is in the running state. Now in an RPG game, normally the player is moving with this animation around, so the player is not walking from point A to point B, but is actually doing something more like this, running. Now which animation do we play when the player wants to move actually quicker? So when he's actually running, well, I go then to 1.5, and now at this 1.5 state I'm just multiplying the animation with a speed factor of 1.5. You can find it here on the top, change animation speed, so and give it a 1.5, so he's actually moving, not moving, but the animation is played 50% faster. Now there are different transitions here, like the crouch transition. So when I press a button to crouch, we go to the crouch blend tree. Here it's the same. We have the speed value between 0 and 1. For the value 0, the player is actually just crouching but not moving. And when it goes to 1, we can see slowly that the player is moving while he's crouched. So this is also a blend tree. And when he's leaving this transition, we have here a condition like move, so from crouch back to move. And here it's shown the crouch condition. So there's a trigger. When it gets triggered, then it goes from this state to this state, and so on. Now let me explain you the jump state. So when the player is jumping, we go to this blend jump animation. So you can see here, at this point he's jumping, but not landing. I want to control how high the player is jumping via code and how long does it take to stay in this land animation. So I will have here another trigger that shows when the player is landing. You can see that it's still smooth to jump and the land, but I can control over a code how long the player will stand before he's again going back to the move function. So between the land and now here the idle, or the land and any other animation that's in this blend tree. You can also go from land immediately to the walk or to the running animation when the player wants to choose that. So there's another transition here, the sprint jump, which I actually haven't shown, but we can also have a definition where the player is sprinting, and while he's sprinting he presses then space, then the player does something called a sprint jump. I can show you it now immediately. So we can normally walk and jump. See, jump and land. You can also move on the rocks there, no problem. And when I press shift, the player is hold shift, sorry. Yeah, when I just press it, here he goes back, but I have to hold it and then click jump. He does this sprint jump. So we can have any sort of animation that we want, no problem. So now let me explain you the character script, which is attached to the player objects, and all the state or state machine script. Now we are in Visual Studio. For the character script, don't forget to import the Unity engine.input system namespace. The character script also inherits from mono behavior. That's why we can see it in as a component on the player object. Now we have a header controls. All these variables are self-explained. Maybe the crouch collider height here. The player has an actual height, or the collider on the player on the character controller, and we change the height by 1.35, so that the start value is 1.8, and here we have now 1.35. The gravity multiplier just means that we are changing the gravity value so that it's more responsive. Jump height, jump, and here some speed values, like rotation speed, how fast we rotate, and so on. Second header is for animation smoothing. So we have a damping time for the speed, so how fast are we moving from the idle animation to the player speed animation, and so on. Velocity damp time, rotation damp time. The air control is how much can the player be moved while he's jumping. So when this value is 0, you have actually no control in the air. When it's 1, you can move completely like he's on the ground. So I have some value between. It's also more player friendly. These definitions are for later, and here we have some values that we have to access in the states. So they need to be public, that's important, but we don't want them to appear in the inspector. So we have this one hide in inspector written above. For the gravity value, minus 1.81. The normal collider height, it's also need to be public, but we can see it down here in the start function. We just read it down from the controller.height. So we save it in this variable. Controller itself also needed in the states later. Player input, camera transform, animator, player velocity. Now in the start function we get our components that we have seen in editor, controller, animator, and player input. Also the camera over camera.main.transform. Now this is also for later. And here our gravity multiplier, just take the gravity value and multiply it with this multiplier. So 1 means it's just a normal value, but I think the value between 2 and 3 is more responsive, so it has a nicer feeling. And this is also for the state machine. So let me explain you the state machine. State machine is just to keep track of what current state is active. So we initialize first our first state. You can see that here in the character script we have here movement SM, so movement SM for the movement state machine that we first write down here, and then we initialize with the first state. Our first state is just the standing state, is where we have the idle animation and the moving and sprinting animation in it. That's why we are standing. Why the word standing? Well, it's the opposite of crouching. So we are sometimes in standing state, sometimes crouching, jumping, landing. Also the sprinting is a bit different to the standing, and the sprint jumping state. So that's initialize. We say our starting state is now our current state, and we trigger the enter function for the state. Now in the change state, we say, okay, what's the new state? Well, first of all, we trigger the exit function, and then the current state gets the new state, and then we also trigger here the enter function. And that's already everything for the state machine. Now for the state class, be careful, it does not inherit from monobehavior, it's a class itself. We have here reference to the character script, state machine. Here are some values, some variables that we use in every state. So every other state that inherits from the class state, these are protected, so we can access them, which is important, but we can only access them from a class that inherits from this state function or state class. Now here we see our input actions that are defined. Also these are public, so we can access from any classroom. This is important. And here we see our first constructor. This constructor takes the character and the state machine object in it. Now we get access to our actions that we defined earlier over this function here, character.playerInput.actions, and we put in the script. So this is important that you put in here the exact name as you have in your action map, and we call them like move action, look action, and so on. This one is much easier to access them later in the actual state that we define later here. Now a state consists of an enter function, exit function as we already have seen, and an handle input, logic update, and physics update. Now where do we trigger these functions? Let's go back to the character script. In the character script we can see here, because it's from monobehavior, on every frame we trigger this update function, and also the handle input and logic update from the state that we are currently in. So we have state machine dot current state. That's, you have to switch here from script to script. So it's the current state that we are in. We then trigger enter, exit, and then on every frame the handle input, and then later after we handled that input, the logic update. And for 60 times frame, so 60 frames per second, we then trigger the physics update function. So this is for all the physics stuff. you can also see that these are virtual functions, so we can override them with every class that inherits from states. And there's one line written here, which then is true for every override function. It's the debug log. It's just to prove that we are actually in that state, so we can control it in the console. Now I go quick over all the states. You can see here that in this part we are defining our different states. So every state is a class itself, and the first line here, that's our state machine. Like the standing state, and here we are putting in with this keyword, we are giving this character, exactly this character object we are putting into the constructor, and here the movement SM is our state machine. And in this line we are initializing the state. So our first state is the standing state. On top we have all our different variables that we need. So jump, crouch, ground and sprint are booleans. So these are important so that we know that we have to change the state. If these are true, we change it. And we have some gravity value, the player speed, current velocity, c velocity, all these values we have to actually move the player. So that would, to explain all this code here, that would be too much for this video. So I just go quick over all the functions. First one here is the constructor. With this base key, we show that we actually have the same constructor syntax as for the state. So the state itself had also this constructor here that gets triggered, and we are using here the same one. So the same variables, character and state machine. For the enter function, the base.enter means that we are triggering also the public virtual void enter function that we have here in the state script. So this line also gets triggered when we trigger this function enter here. That's with this line. We initialize all our variables to 0 or to false, and then we are getting the information from our character script. Handle input, we are looking if these actions are triggered. So jump action dot triggered. If we press space, this is true. If we press C, this is true. If we press shift, this is true. And here with move.action we actually can read this value, this vector 2 value, because our move action is this WASD action where we get the vector 2 from it, so we can read it. So this here are all the actual movement parts. If there is some interest in this part or in the physics update, I can explain this more in detail, but I keep this now short because this has not actually something to do with the state machine itself. It's just how to move a player. Also in the logic update, it's where everything comes that has to do with the animator. So here we are actually setting the speed value we have seen in the animator, and with the speed damp time here, how smooth it is. In this function we also check if the sprint, jump or crouch boolean is now true. If it's true, we change the actual state, which is change state function. Now character dot sprinting, character jumping, these are all names from the states that are defined here. Physics update, as I said, this is for all the physics stuff. So here are we actually moving the player with the character.controller.move function, and we put in here our velocity and our gravity. Here we are also applying the gravity itself and rotating the player with quaternions and so on. So if you want some more explanation to this, you can do it in another video. And the exit function at the end. So we are putting here the gravity to 0 because maybe the other state does not have gravity in it, and then we don't want to apply gravity, so just make this one to 0 and also rotate the player at the end so he's facing the correct direction. Now when the player is actually pressing the space button, then this jump boolean gets true and we change the state to character.jumping. And in the jumping state, we see here on top all the values that we need. Again, the constructor, and here now we get all the values from the character script. We are setting our animator values to, let's say, speed to 0, and we trigger the jump. So also in the animator we are moving from the basic locomotion blend tree to the actual jump state in the animator, and we trigger the jump function. Jump functions here, again this is physics, so here with jump height value we can define how high the player will jump, and then handle input. So as I said before, we have also an air control. No, it's not here. The air control parameter comes down here. So with character.airControl here, so we can change between 0 and 1 how much we can actually move the player. With the input value here that we read also again from the move action function, we can move the player while he's jumping. Logic update checks if the player is grounded. Now this one will not be checked in the handle input because it's not really from an input, but it comes more from the physics update. So this physics update, after we check if he's not grounded, when he's not grounded, he moves down. If we have an air control that is not 0, we can also move a bit the player around while he's jumping, and then when he's finished, then we check if the player is now grounded. When he's grounded, this one will be true, and then on the next frame we have if grounded is true, then we change actually the state to the landing. So when he's grounded, he will be in the landing state. Now at the landing state, again we have here the variables that we need. The landing time is how much time will pass doing that state. It is here hard coded as 0.5. You could change this one also to a variable that you can access in the inspector in the character script, but I just hard coded because I find like 0.5 seconds is enough to stay in that state. You could also just completely ignore that state if you don't want the player to land for any amount of time, but I find this more looks a bit better and it shows, like as an example, how much you can control this state machines. The set trigger will be in the enter function, and then the set trigger here in the logic update. So when this time is passed, when it's more than 0.5 seconds in it, then we trigger the move trigger that it goes back to our locomotion blend tree. And we of course change also the state to character.standing. So we are again back at this state. This goes from standing state to jumping state to landing state, and again to the standing state. So it's a cycle. Now in the crouching state, also here we have all the variables that we need. Again the constructor, enter function, we set our trigger here to crouch. We have a below ceiling value. This is like when the player is under something that he cannot stand up. So this will be false at the beginning, and with an raycast we will check if actually there's something over the player or not. So this check collision overlap function, and with this one, there's a boolean function that will check if there's something above the player. When there's something, it will return true, so the player cannot stand up. If there's nothing over him, this will return false, so the player can stand up. So now we have also here our variables again that we get from our character script, like this one, character height, crouch collider height, and this will be the actual collider height while we are crouching. And yes, we have also to change the center, because otherwise it will not work properly. I've put in here the exit function because it's very convenient to see that we also change here the center and height back to the normal values. That's why we have here a normal collider height, which is also a variable in the character script. Now we are also changing here the trigger to move when we exit, and we just save our player velocity, because maybe you want to move during your crouch state, and when you go back to the normal standing state while you are moving, you don't want the player to wait for a second to actually move, but you want to immediately go to the moving part from the standing state. That's why we also save here this value. Handle input function. Here we look if a crouch action is triggered. Now we also have to check if there's nothing above the player. If there's anything above the player, then he cannot stand up. This is important. And here we are reading, because we also want to move actually during the crouching. So this part is very similar to the standing state part. Logic update. Here we are setting just our animator that we are actually moving, then we're changing the speed value, also speed down, so we're smoothing a bit. Now when we are not longer crouching, then we go back to the standing state. Physics update is now a bit more complicated, because here we are actually checking with this check collision overlap function if there's something above the player. Again, this has to do with physics, so we are of course doing it in the physics update function. Here we also apply gravity, we are lerping a bit, we are moving the player and so on. Again, very similar to the standing state, a bit too complicated to explain this one here in this video. If the player is pressing the shift button while he is also moving, then we are going to the sprint state. So on top we see again all the variables that we need. We have a constructor and we have the enter function. Enter function, again, first part here we are setting all our variables to 0, and in the second part we're getting all our information from the character script. Handle input. Here again we are reading our from our move action our vector 2, setting our velocity, and now this if condition is a bit different. So to stand in the sprint state, we actually have to holding down the sprint action and to moving in any direction. So pressing the W, A, S or D key. If that's not the case, then the input or input.square magnitude will be 0. So we are no longer sprinting and setting the bool sprint variable to false. The same is if we are not pressing down our sprint action, then it's the same, we are also not moving. Or let's say if we are releasing the sprint action, because we have it defined as pressing or releasing, then it gets triggered. It will be false and we will be leaving the sprint state. If both conditions are false, then we are keep being in the sprint state. So sprint will remain true. So that means we have to move and we have to pressing the shift button. Now, as a bonus, we can also have a condition like this. So when we are in the sprinting state and we are pressing jump, so shift and jump, we can have an additional state like the sprint jump state I have defined here. And this will be true. Logic update, we are checking if we are actually in the sprinting state. So if the boolean sprint is true, then we are setting the animator values correctly. If not, we are leaving the state and going back to standing state. If our sprint jump boolean is true, then we are also changing into the sprint jumping state. In the physics update, well, we are still player controller that use gravity. So again, this part is about gravity. We are also moving the player, so we need the move function from the controller, and we are rotating the player. So this part is very similar to the standing state part. The last state is a bit like a bonus state, because in this one we're also using root motion, so you can actually change with in the root motion from the animator if you want to play an animation that uses root motion. So in this one here, we're also saying that we are in some time into the state, so have time pass and jump time. Now for the jump time, again, it's hard coded here. The same as for the landing state, you can define a new variable in the inspector or in the character script that you can access in the inspector, and then you can change it, have it hard coded now here. So this set trigger sprint jump so is as usual. The only line that's new is here this character.animator.apply root motion, which then will be true, and when we are leaving the state, then we have to set it back to false, because all the other animations do not use root motion. So it's important to also in the exit function set it again to false. Now the logic update is similar to the landing state. We are just waiting this 1 second, and then after that we are triggering the move trigger so that we're going back to a standing state. And then, well, in this case it's even the sprinting state. Now that's it for this video. I hope you found it helpful. In the description you can find all the resources that I used, and also the models that are in the background, as well as the character model and the animations. Yeah, and by the way, I will be reading and replying to every single comment, so feel free to add any suggestions or to ask questions. See you next time.